can we have a right triangle so that the perimeter is equal to 1 meter and the area is equal to 1 square meter? Yes, we did a similar question last time with a rectangle, but this time it's about a right triangle. And I will tell you, this right here is impossible in the real world, so it's a no. However, I do want to tell you, it is possible for a right triangle to have the same perimeter and the area numerically, but not 1. 24 will work. I will show you guys that later, but let me just show you guys why this is not possible. Here we go. Firstly, let's consider a right triangle like this. I'm just going to put on this side to be A, and this is B, and this is C. So, of course, perimeter is equal to 1. That means A plus B plus C is equal to 1. And then the area is equal to 1 means base times height. In this case, A will be acting as the height. So we can just say A times B divided by 2 is equal to 1. So this is what we are trying to achieve. And now, let me just show you. Perhaps I'm going to move the C to the other side so we can look at A plus B equals 1 minus C. And this right here is the same as saying AB is equal to 2 times 1. Because we have A times B and we have A plus B right here, let's go ahead and square both sides, because that way we get A squared plus 2AB and then plus B squared. And then right hand side we get 1 minus 2C plus C squared. But what's C squared? Well, this is the right triangle, so it must satisfy the Pythagorean theorem. So that means C squared has to be the same as A squared plus B squared. So we can put that right here. So in fact, we can cancel out A squared from both sides and then B squared from both sides. So this right here is gone now. That means we have 2. And then the AB is equal to what? 2 right here. And that's equal to 1 minus 2C. And let's just go ahead and continue. This right here is 4. That's equal to 1 minus 2C. And that means 3 is equal to negative 2C. And C is equal to 3 over negative 2, which is negative 3/2. Have a look. Is it possible for us to have C equals a negative number? Impossible. Right? Impossible in the real world. If you do want to continue, of course you can put negative 3 over 2 into the C here and then square that and then make that equal A squared plus B squared and try to figure out the imaginary side of A and B, and then you can go from there and all that good stuff. But I think we have reached a contradiction, so we don't have to continue anymore. So I'm going to begin right here. Because perimeter is equal to 1, which again implies that A plus B plus C is equal to 1. And of course we have the Pythagorean theorem here, and you can also just take the square roots both sides and say C is equal to the square root of all that. Good. Now here's the point. When we have a right triangle, this right here is our perimeter, we actually can figure out the maximum possible area of the right triangle. I will tell you though, the maximum of the area, it's going to be a isosceles triangle. It's going to be something like this. Yes, I will write this down. It has to be the case when A is equal to B. They have to be equal in order to have the maximum length, in order to have the maximum area. And you can think about why, but usually you just want to keep things balanced. Just like when you have a perimeter, when you have a fixed perimeter, you want to get the biggest area, you want a square, but you can work out the detail on your own. Anyways, so what does this mean? I will just write this down. The maximum area happens when we have this. So I'll just call this A and that's A as well, and this is still C. So that means C is equal to square root of A squared plus A squared, which is just A times square root of 2, or A times square root of 2, just like that. So this means we have A plus B is again the same as A, and C is a square root of 2, which is equal to 1. That means, well, this is square root of 2, so this is 2a. So we can do 2a plus a square root of 2 is equal to 1, and then factor out the a. So it's a times 2 plus square root of 2 is equal to 1. Then divide both sides by this, so a is equal to 1 over 2 plus square root of 2. That's not what we're about to simplify. The rationalize the denominator and all that stuff. So the maximum area is going to be when a is equal to this number, and of course the area is base times height. But they are the same now, right? They are the same, so we just have to do 1/2 times a, which is 1 over 2 plus square root of 2, and then times another one, so 1 over 2 plus square root of 2. This is the maximum area. Have a look, we have 1 times 1 times 1 on the top, and everything on the bottom is bigger than 1. So when you multiply this out, for sure, you get something less than 1. The maximum area is less than 1, so it's not going to be equal to 1. If you have this triangle, 6, 8, and 10, the area is 6 times 8, which divided by 2 is 24, let's say, meter square, and the perimeter, 6 plus 8 plus 10 is 24 meters. This is just a straightforward triangle, but you just double it. Can you think about more triangles? Maybe just stick with the right triangles, so that we have the same numerical value of the area and perimeter.